Hello friends, this is Gangadhar from Maths Ganga, and now I have another question on the board asked in JEE Main January 2019 from the chapter Functions. Let us see the question. The question is given like this. I have two functions f and g. Both the functions are from natural numbers to the natural numbers, and f of x is defined like this. F of x is x plus 1 by 2 if x is odd, and then f of x is x by 2 if x is even. Coming to g of x, it is defined like this: x minus of minus 1 to the power x. Then we need to check about f of g of x, composition of f over g, whether it is 1 1 onto, many 1 onto, 1 1 not onto, not 1 1 not onto. See, I have two functions f and g. I need to decide about f of g of x. So for that, what I am going to do is I need to write the functional expression for f of g of x. See, here we have two chances. Since it is given like minus 1 to the power x, we need to think about x, whether it is even or odd. So I have two cases for x. If x is even as well as if x is odd. If x is even, minus 1 to the power even number is 1. So g of x will become like x minus 1. Whereas if x is odd, minus 1 to the power odd number is minus 1. So x minus of minus 1 is x plus 1. Now if you think, since x is even, this x minus 1 is odd. Whereas since x is odd, this x plus 1 is even. Now I am going to write f of g of x. In this case, this x minus 1 is odd, that means g of x is odd, so we go with this definition. With this definition, I have x minus 1 in the place of g of x, so x minus 1 plus 1 by 2, and it results to x by 2. Whereas in this case, since x is odd, x plus 1 is even, g of x is even, so we need to go with this definition. As g of x is even, the result is g of x by 2, that means x plus 1 by 2. So finally what I have, f of g of x is x by 2 if x is even, and f of g of x is x plus 1 by 2 if x is odd. So we need to check whether it is 1 1 or not. See, it is clearly explained that x by 2 and x plus 1 by 2. So okay, for some values, both x by 2 and x plus 1 by 2 are same. For suppose, I have 3 in the domain of natural numbers and 4 in the domain of natural numbers. Since 3 is odd, with this definition, f of g of x will maps to 3 plus 1 by 2, that means 4 by 2, which is 2. And if 4 is the number in the domain of natural numbers and 4 is an even, with this definition, f of g of x maps to 4 by 2. That means again it is mapping to 2. That means 3 and 4 both have same image in the codomain. That represents that f of g of x is not 1 1 and f of g of x is many to 1. So f of g of x is many 1. And the next thing is we need to check whether it is onto or not. To say whether a function is onto or not, we need to check whether every element of the codomain has p image or not in the domain. See, if you take any element in the codomain is what here? Natural numbers. For f of g of x is also, since both are from 9 to n, f of g of x is also from n to n. So we need to check this f of g of x is also a function from natural numbers to natural numbers. We need to collect the numbers in the codomain of naturals, and corresponding to that, if we have pre-image in the domain, then it is onto. For suppose, if you take a number 1 in the natural numbers, clearly this 1 has a pre-image such that 2 by 2, it maps to 1. And if you take 2, then it is mapping from something like 3 to 2, and then 4 to also 2. And if you have 3, then 6 is mapping to 3. See, as per by the definition of x by 2, every number in the, if you have a natural number in the codomain set, its double is surely there in the domain set. Okay, if it's an even. In the same way, if it is odd also, we have the, with this definition, we have an pre-image for every number of the codomain. So with this check, it is enough to say that f of g of x is onto also. So finally what I conclude is, The function f of g of x is many 1 as well as onto. And your answer is option B for this question. Thank you.